How do you replace almost a quarter of a house with glass and have it not fall down and also take care of thermal bridging and insulation? Let's find out today on Smith House. Howdy y'all, my name is Jordan Smith. I am a design builder with Smith House Company. We design, build, and remodel houses around the Austin, Texas area, and I also do consulting for clients across the US. Today I want to talk about a new design build that we're just getting dangerously close to finishing up now, and specifically want to talk about this big window wall that's just really cool. I think it's really cool. It takes up almost a quarter of the house. They are 30 feet wide by 20 foot tall on the north facing wall, and that same 20 feet tall by 18 foot wide on the east facing wall. Just really large windows. And we knew when we started working with the owners very early on, they said, hey, we want to be able to see out of this house with very little obstruction on these two ponds that we're putting in on this property. And I thought it was a great idea, so I drew this concept up where I had these Doug fir columns and the rafters rested right on top of it, and it was all going to be a mass timber design. And my engineers came back and said, look, we don't mind you setting your rafters on top of your columns like this, but you're going to have more structure in order to keep it from racking or to resist the shear load on this. So you have to put in brace frames. So I'm going to get into a little bit of the steel, and then I'm going to talk about the wood substructure, and then I'm going to talk about how all the windows come together. So here is a picture of the house. Not yet complete. The rail's not on yet, and the landscaping's not in, but those windows are complete in this picture, and it just really looks nice. But there was so much work that went in both design and in building to pull this off. Let's look at the windows real quickly, and I'm going to come back into this later and we're going to talk in more detail, but just so everybody's on the same page, the general idea is it's a veneer track. That's what Oldcastle calls it. Stabilux, they're out of Germany, they call it something else. Everybody, YKK, Oldcastle, Stabilux, nearly all the big window extrusion manufacturers, the aluminum extrusion manufacturers, will make a version of this that is intended to go on either steel or on top of wood. In this case, even though we didn't use Stabilux, I like Stabilux's graphics. They show how the wood column is there, and you're screwing that aluminum track onto the wood, and then you're encapsulating your glass with this cap channel there. So one of the problems with replacing so much of the structure with glass is, like I said, you're not going to be able to resist this shear anymore. The engineer says, hey, we're going to need to put in brace frames. So if you look there on the right side of this image, there's a brace frame. That's the two columns that have the triangulation braces down it. And that keeps this building from falling over this way. And then we've got another one in the back, and we've got a few more scattered around. And that gives this building all of the structure. We just from a design standpoint, the engineer said, oh, well, you could clad the beams if you don't want it to be shown. And I'm like, look, if we're using steel, let's use steel. Again, truth in materials, just be yourself, man. If we're using steel, let's show the steel. So that led to this hybrid wood and steel mix, which I think looks really good. Honestly, I think it looks better than my original design. Again, I came in and I designed the steel. I drew the steel. I did all the shop drawings. I did everything, but I always had everything verified and redrawn and stamped by the engineers, because they're the ones that are saying this beam needs to be at least this big. And then I would come back and I'd oversize some of the other beams so we'd have consistency in massing, even though they're not directly needed on some of these to be this big. That big first forward beam is like 18 inches tall, and that sort of set the sizing for everything else. We used brackets up on top, and we clamped the wood rafters or beams. Brafters is what I've been calling them. We captured the brafters with these brackets, and then you'll see here in a second, all those brackets get covered up except for the outboard most ones, the one over that side porch there. You're able to see, and you'll be able to see, we're not covering them up at all. On top of those rafters, we did a 2x6 decking. So those rafters are happening at a 6-foot interval, and that decking is able to span that 6 foot, no problem. You can go up to 8 feet. I felt like 4 feet was too narrow, and I felt like 8 feet was too much. So I did 6 feet. In retrospect, I probably would do the same thing because it just fits the repetition that I was looking for on this building. But it did make it sort of a pain because none of your sheet goods come in 8 foot. You know, they're 8 or 4. I'm sorry. None of the sheet goods come in 6 foot. They come in either 8 or 4. And it was just a little bit more of a pain for the framers, but it still looks, in my opinion, it looks the best on the 6 foot. You see that overhang there on the left-hand side of the picture. Because we're using 2x6 decking, we're able to do that on this side without any other support. There's a lot more stuff that went into that roof, but that's a whole other video. If you're interested, comment below and I'll do a roof video. Here it is again, and you can see the transition from partially complete to fully complete. We've got that beautiful Doug fir decking. That's clear Doug fir. Clear Doug fir decking means that it's going to be almost completely knot free, but it's not 100% knot free. This is a close-up of our brackets there. We're supporting just on wedges, simple wedges. That's wedged under there to give an even loading of this beam, and then we're bracketed on. And then underneath, you can see these tabs that are welded on. Those tabs are what are going to receive the Doug fir columns that are going to be acting as the structure for the windows. And here's those columns that have come in. Originally, these columns were supposed to be structural, and I guess technically they sort of are. They're limiting deflection, but that beam up there is more than enough to hold all of the weight of the roof. This is a 15-foot cantilevered overhang, so we uplift and a whole lot of other stuff goes into the engineering of that. Again, I can talk about that on the roof video, but these vertical columns are there just to support the windows that are going to be coming in. Then we put in our cross section. So this midspan wasn't necessary structurally, but architecturally, I wanted to break it up. I didn't want to just have a huge expanse of glass. We considered it early on as just going floor to ceiling, but you jump in price very quickly as you go taller. The first window or glazing company that I was talking to, they're like, oh yeah, we can do a 20-foot piece of glass, no problem. I was like, sweet, no problem, no problems, no problem. And then we get further down the design and we start getting some bids, and they come back with this glazing package, the 20-foot section. And they're like, look, you can save $100,000 on the package if you broke this window up somewhere. And I'm like, what part of no problem do we have a disagreement on? Like when I say something's no problem, I would say it's doable, but just be aware it's going to cost you another $100,000 if you go floor to ceiling. And if you break it up, you can save a smooth $100,000. I was like, that's sort of a problem. So it's the right decision architecturally. And then that just made it like, oh, well, there's absolutely no reason to go floor to ceiling. So we broke it up. So we've basically got 11 foot 4 inches for the first height. Then the second unit is going to be 2 foot tall. And then that top is a 6x6 square. Again, all of these are 6 foot wide. This is some of the hardware that it takes to put this in. We went with a Simpson post base, a timber frame post base, knife edge post base that they're selling now. And this is from the outside. We do not have any kerf on the inside. On the inside, you'll see some pictures later. It just looks like it's magically attached. We don't have any hold downs. We don't have anything from the inside that gives away how it's attached. This is all from the outside, and then we cover this up with tape. Over here on the left-hand side, you see that we've got this bracket. This is just a simple angle iron bracket that is lag bolted into the vertical columns. Again, all of this stuff is my design from a how about we do this, but we ran everything through our structural engineers to ensure that it was satisfactory from a load standpoint. And if you're doing this on your own, I highly recommend paying an engineer just to go through and verify your calculations. So here you can see that we've covered up the cut in the backside of our Doug fir. This Doug fir beam that is down on the slab is held up by a foam. So we've got a sill block across the bottom that keeps any capillary action from wicking water up into the bottom. And then it's taped with Sega tape down to the slab, and that seals all of the air and water from the bottom. And then we add brake metal that just makes it really nice and clean. And then that vertical and horizontal, that third picture there, you can see the T of the window system, that first layer of the window system going in, and it just looks so clean. Here is how that window system looks. So that T that you see up on that third picture, you can see on this one where the screws are going through and into the wood behind. So those anchors are pulling it into the wood. We have got a T bracket, and then we also have thermal brakes between everything. That's one of the big comments that I get on this system is people are always asking like, what are you doing for thermal brakes? Or you're going to have so much condensation on the inside, or I give it 10 years tops, or the world's going to end. No, it's not, because we're thermally braking everything. We've got a rubber thermal brake between the cap and the T bracket. Our screws have a polymer washer that also thermal brakes the screw from the cap so it doesn't transfer it down into the T. We've got our gaskets holding in the glass, so the glass is thermally broken from the aluminum on both sides, as well as air sealed. And then we've got the little braces that hold the glass up off the T bracket, which is also a little bit of a thermal break, although you don't get that much thermal transfer through the glass. So everything is disconnected. The inside T bracket is not connected with a metal conductor all the way to the outside. We've got thermal brakes all the way through. So here is the picture of, we've got our beams, and you see that black highlighter over there is our T bracket that is going to accept the glass into it. So we've got the T here, and the glass is going to sit here, and then we're going to put a cap on top right there. This is a good picture that you can see. The right-hand side, you see that top bracket, that aluminum bracket has been pulled out. They were doing some work to get it all put together, so this isn't usually how it goes together, but it's the best picture I had to show. You see on the left-hand side of the picture, you see the black top cap has been put on, so that's finished. And then in the middle, you see that pressure plate that is holding the glass into the unit. And then on the right, you see that pressure plate has been pulled up, and you can sort of see, not really see on this, but you can sort of see some of the insulation members that go on the inside of that. So that will get pushed up against the glass. Everything's thermally broken. That aluminum on the outside does not touch the aluminum on the inside. Everything's broken with rubber or gaskets. And then on the right-hand side there, you can see the completed unit right after they finished putting it in. Just super clean, really small. This is a 2.5 inch sight line, so it's a 2.5 inch front face on this, and it just looks really, really nice. So here it is from the exterior, and again, because we love truth in materials, we're covering up these steel beams on the inside just because we want to be insulated. So our I-beams have insulation on the inside, and we're completely boxing those out, so you don't see those from the inside. But we did want to express it on the outside. So on the outside, you see a steel column, and you see the steel I-beam, and from the inside, it all is wood. And I really like the way that it's looking. Here's some more completed pictures. Again, these aren't final pictures. As we get as we finish up, I'll take some more pictures and we'll do another walkthrough on the final house. But on the windows, you see here, it just looks really, really nice. The window lines and the columns line directly up with the rafters above, and it just looks very structured. And that is how we put in a 20-foot tall, 30-foot wide window. It's not just as easy as deleting the wall and adding the glass. There's a lot of engineering that goes into it to make sure this thing doesn't fall down, that it doesn't get pushed in, that it doesn't leak, on and on and on. But I hope that helps you understand what it takes to put this in. The things that I would say to pay attention to are, make sure you have a plan to seal this unit at the top, the bottom, and the sides. In the middle, it's all going to be the window manufacturer. He's going to be putting in the glass into the gaskets that seal everything out. So that will be fine, but where it terminates to your wall on either side, and where it terminates to your slab or foundation below, and where it terminates above, you gotta have a plan on there. We used a mixture of tapes and the zip fluid applied or whatever, Proseco, whatever your favorite brand of fluid applied is. We love that stuff because you can just get in and you really detail and make sure that everything is sealed up. And then once it's all sealed up, we use brake metal to cover up a lot of those transitions between the stone and the window, and it looks just really nice when it's all said and done, just all black and crisp. Thanks so much for watching. If you have questions, and I'm sure some of you are like, what in the world is he talking about? If you have questions, if I haven't explained something well enough, comment below. If you want to talk to me about consulting on your own build, I actually had a guy call me the other day and said, hey, those windows, I'm doing the same thing on mine. I'd love to pick your brain about it. Go over to smithhouseco.com, go to contact us, select consulting, and we can talk, man. I love talking about this stuff. I'd love to walk you through exactly how we're doing it, and I'd love to give you my opinions on what you're working on as well. Thanks so much for watching. I hope you all have a good one. Go check us out at Instagram and TikTok and everywhere else, Smith House Co. and George Smith Builds, and we'll see you next time on Smith House.